Hi everyone, Zach here, and welcome to the fourth lesson in this C++ tutorial series. In this lesson, we'll go over a bit more on our variables, a bit on project setup with regards to thinking about what we need to consider for game development, and then at the end of this lesson, I'll go over the solutions from last week's challenges. So the outline of this session is we're going to cover our variable and our declaration types. And then we'll talk about project structure. So you've heard me mention in previous lessons or in the RTS tutorial series, global versus local variables. And they're fairly simple. And in a lot of cases in things outside of game development, we're going to work more with local than global variables. But in game development, we do use both, and we do use global a fair amount. So a local variable is simply a variable that is declared and initialized within a function. So far, our function has been the int main bracket. So when we declare a variable within there, it is a local variable. This means that variable can only be accessed within there. So when we say accessed, we mean used. On the other hand, a global variable is declared outside of any function and thus can be accessed anywhere. The way this might look is something similar to this. So on our left, we have our global example of, a bank balance being declared as an int. Though, to be fair, that really should probably be a float because, dollars and cents. And on the right, we have a local version of this. So at the top, we have our include IO stream, our header files. Then on the global, we declare a integer value, again, that should probably be a float, of bank balance. We then have our function, which I've used a void main here instead of an int main. And we initialize our bank balance as 0 in that function. On the right, we go straight into our function where we declare our bank balance as an integer and then initialize it. So if I were to then create another function, say in our local one, called myTest, I couldn't then print out the bank balance. This code would return an error because I am trying to use the variable, a local variable, in a different function. So local kind of just means it's local to that function. Now, the other thing we need to consider are unsigned versus signed variables. By default, all integers and all variables are signed. And we think about this in terms of numeric variables. A signed variable has positive and negative values. An unsigned has negative values only. Now, why might you use these? Well, when you're doing certain things with memory allocation or dealing with sound files, there are various reasons to use them. And typically, we really don't need to worry about these differences when we're starting out. Now, it can give your code some structure to use these values. Sorry, unsigned is pos values only. I said negative values only. So if you want something that can only, if you want to remind another coder, or if you want to make sure that a value is only positive, yeah, it does give your code some structure to use an unsigned variable. And the way you might do that is you'd write unsigned variable type, so integer in this case, and then your variable name. Note those brackets are just there to say, fill in the variable name here. You won't need those actual brackets. So that kind of brings us to our headers. Since we've talked a lot about, declaring variables, we've talked about different ways of doing it, we need to consider, some good practice. And headers are kind of a great place to start there. And when you declare your variables, good practice says you need to declare them near where you use them. However, to declare variables in advance, to declare our algorithms, to set everything up, can get messy, especially as we add more and more things in. And also, we might want to use the same, variables, for example, health, or algorithms, so damage taken, so functions, across multiple classes. So the easiest way to handle that is to use headers. So headers include our declarations. These declarations are then used by other class files. So for example, we've been using the header IOStream. This contains the information needed for cin and cout we've used. These are predefined, variables inside IOStream. They are declared already there. They're forward declarations. If we didn't have this, then we would have to write out manually or type in or copy the declarations related to cout and cin each time we want, each class that we want you to use it in. So this makes our life a bit easier. It makes things neater and nicer to work with. Now this can be a very hard concept to conceptualize, so I have a visual representation for you as well. So I realize this graph might be a bit confusing to some people. The way we're going to think about this is we're going to handle our branches individually. And by branches I mean our health branch is one thing, and we'll then talk about our character branch as another. At the end, we'll talk about how they come together in this main branch here of this game class. So our end result in our game, what we want to have happen, is we want our health and our character information to be included in our output, our game file. For this to make sense, for this to work easily, what we want to do is we want to declare certain things in terms of our health and certain things in terms of our character. So, for example, our health might be defined by our character's physical size and our current level. So, in our health CPP file, we might have a calculation that goes, X multiplied by Y, pardon my horrible handwriting, equals our health. This is actually really hard to do, the writing that is. So we have X times Y equals health. Well, we haven't declared X and Y in our health class file, the CCP file. Where we'll declare it is in this header over here. And in here we're going to do, X is an int or a float, and Y is an int as well. So we'll declare them in there. I know I'm writing this backwards, I'm sorry about that. And it brings it in, and the class file, this CPP file, takes these declarations, knows what X and Y are, multiplies them together, and gives us our health. Then our character file might say, bring this information over, include the health as part of a component of it. So we are going to have health as part of our character file. So any function related to health, anything that might modify health. So let's say, we have something in a particular character class that boosts health. We might take our health function from our health CPP file and multiply it by a buff of some sort, to use some game terms. So we have a buff in there that modifies our health. Well, we need the game entire to recognize both the health CPP and the character CPP. So the character class and the health class. And the way this works is just like with our IOStream, in our main file, so in our main class, we declare our headers at the top to include health and character. When we compile it, what happens is the compiler will create an object file for our health. So our health one there, an object file for our game, and our object file for our character. Because our game object file, our main file, includes links to our health and our character in the headers here and here, it's going to, then link them down here using a standard runtime library and bring them together in our final file, the executable file, our game.exe. So what's happening is when we say, game class file to include our health, it goes, okay, we need to include these variables. The way these variables are used are declared by this health CPP. The linker brings the object from health CPP, our class file, into our game exe in relation to our, game object file here. Overall, this concept might seem rather tricky, but in reality, it's rather simple. It is so simple that it actually becomes complex. It's one of those things that takes a little bit of time to kind of wrap your head around, and simply because we tend to overthink these things. To help you with that, I'm going to include some links down in the description that might help explain this a bit better. Outside of that, next thing we're going to do is we're going to look at the solutions from last week. So let's get to the part of the tutorial that you're all really here for, the solutions to last week's problems. So we're going to start with the first challenge, the first actual challenge, not that optional at the start, which is to build a game that asks the user to guess the computer's favorite color, and where no matter what the user puts in, that will be the answer the system accepts. So there are a few ways to approach any of these problems, by the way. So we'll start with the simple solutions, I call it, which is using material we already have. So as you can see, we have our normal include header, include IO stream, and our main function. In here, we declare our favorite color. We declare a character, so a primitive variable of character. We name it fav color. We then ask for the user to guess their favorite color. Notice I don't have an end line. I still have that extra space though. We then declare the fav color variable, which is a character, on the console in, and then it will respond by saying, amazing, that's my favorite color. Now before I run this, I'm going to tell you there is a problem with this. There are a few problems with this, in fact, actually. So let's just see what that issue is. So I run it once it compiles, and you'll notice that it says guess what my favorite color is. Notice the line we are typing on is the same line as which this text shows up. That isn't a problem. I'm just explaining why this is. The reason why it's on the same line is we haven't put a stroke n in here. We haven't put a standard end line here. So it's just going, I should be on the same line. Alright, I'm going to pick a simple color. I'm going to pick green. And no, green is not my favorite color. And you'll notice, though, that it returns, amazing, G is my favorite color instead of green. Again, that character is only looking for one value. So what we can do to fix that, however, is we can go to where we declare it, and we can put a square bracket in, and we can give a certain size. Let's say we're going to give it a size of 2. We're going to run into an error, however, when we do this. I'm going to use the same color again. We're going to type in green. Now you notice the debugger has pulled us over into a area saying, hey, there's an error. It's saved green, but it's going, hey, we've handled a problem for you. And the reason why this might be important, I also need to close that out, is, let's say we use this value of 10. You're thinking, hey, there's not many colors that have a value greater than 10. Well, you're going to be true, because it took me a while to find a list of colors that had more than 10 letters. And I'll say only one of them is no, 2 of them on this list are actually singular words and not hyphenated. So let's try that for a second. Let's try one of those longer ones, see what happens. If we type in amaranth, we get that same error because we have 11 characters instead of 10. So there's still some problems there. Or let's do one more. We'll do, just because this is hilarious on this list, duck egg blue. And you get duck egg instead. So there are things like saddle brown, Papayan red. I'm Venetian red, I am just literally reading from this list of colors. Um, so to handle that, what we can do instead is instead of using character, instead of having to worry about declaring how much space we need to allocate for it, we can use strings in its place. So let me just comment this out real quick, and we'll collapse these down. And we'll go to our more advanced solution, which uses strings. So here again, we declare our header, our standard pre-compiler header, our IO stream, and now we're going to include something that is called string. String also uses the standard library namespace. It has an std namespace in it. So when we go into our main when we go into our main function, we can see we're using that standard library to declare a string. We're declaring it as a favorite color. Now again, we have this entire thing, and that's correct. Where we say, "Hey, human, what's my favorite color? Take a guess." I imagine my computer as being a snarky beer can named Skippy. Yes, I am referencing a sci-fi novel there. Again, standard library, cout, take a guess what my favorite color is. Again, I just like having the answers on the same line, which I mean by it's not needed, but we will need it as it will answer on the same line is what I really mean. So because we're answering on the same line, and what I mean by next line is next line of code, so I'll just be clear. So we're answering on the same console line. So when we run the console, this will all be on one line, as you've seen. You can have the stroke on, it will drop down the line, or you can have the std end line. That is all up to you and how you think it should look. Now, what's different here is if you try to use a standard C, and in fact, let's try that right now. Let's get rid of this get line real quick. Get rid of this extra bracket here, and let's input fave color from our C line. You'll notice you'll get an error. It won't compile. Okay. Interesting. I said it wouldn't compile, but yet it just did. In earlier versions of this, when I tried to do that, it gave me issues. So the other option, if you do get an issue where it's saying you are missing a semicolon, even though all your semicolons are there, what you can do is use getLine. And what getLine will do is it will get everything on a particular line. So in this case, it's going to get we're telling it what to get inside the brackets. We're saying get the console in, and from there, declare your favorite color. So we'll try a different color. So purple works. Now let's try that, what was it, duck egg blue I tried? I love how liver color is on there. Yeah, it was duck egg blue. Duck egg blue. And you'll notice now the string is picking up that space. So with characters, we don't get that space, but with string, we do. So let's collapse this one. Actually, sorry, let's comment this one out and collapse it. Again, there are multiple ways to have done this. Whatever approach you used, as long as it works. Now let's get to the actual tricky one. And I already have a note open about this one, but the tricky one was the second challenge, which was to build a game where the user must guess a random number, and multiple guesses are allowed. Now, you can be really mean and, just say, hey, I'm going to put any random number in the world in there and see what comes out. And I'll show you why that's me with the optional challenge at the end here, the one from the very start of the last week's video. But I just want to point out there are multiple ways to do this. And in some cases, you're going to need to use multiple libraries to get this to work. In fact, you will need to use multiple libraries to get this to work. So we first have our include. And I'm going to put up the buggy code first. So we have our pre-compiler header. We have our IO stream. And then we have the C standard library. And from the C standard library, this is where my rand function is coming from. So I'm getting my rand function from this library. That's the only thing I'm getting from here. You could use the random library. You could use the little bit outdated library of standard library.h, and those libraries are still around, but they are not standard use anymore. Now, what's going to happen is, after I'm going to uncomment this, you'll see there's a problem with this. But I'm not going to show you the problem right away. I'm just going to let you work it out as we go through this. Now, the problem isn't actually in the code. There's nothing wrong with what I've written so far. So again, we have our main function. We have a new way of declaring our variables. I'm just showing you this for the hell of showing it to you. Now, this isn't a way I would normally declare variables, but if you want to declare multiple integers in one go, this is an acceptable way. It can lead to problems. It also is not a standard way I would do it. Personally, what I would do is I would use a C++11 constructor. So I'd use the not the curly bracket and then put a 0 in and declare each one on separate lines. But, you know, I like when I'm doing things at the start not to give them a starting value, not to initialize them as well. And that's simply because if I forget to use that variable, I like the compiler yelling at me, hey, dude, you forgot to use this. The next thing we have is when we set our favorite number. So this is a little bit confusing, so I'm just going to walk you through this piece by piece. And what we're going to do to walk through this piece by piece is we're just going to lower that down for line. So take our favorite number and declare it as equal to a random number. What's going to happen here is it's going to pick a random number between 0 and its max, which is, I'm not going to read the number out, I'm just going to type the number out for you. So it picks a number between there, 0, and there. In fact, I'll actually just comment this out for a second. And we're going to put some brackets around this as well. So rand returns a value between 0 and this massive number. Now, if you want your user to go insane guessing at the computer's favorite number, you can. But, you know, let's not be that mean. So what we're going to use is we're going to use something known as a modulus operator. I'm probably mispronouncing that. Sorry about that. So a modulus operator is our percent sign. What it really is in this case is actually a division sign, top and bottom there. So what we want to do is we want to divide it by something. Well, if we want a value between, say, 0 and 10, then we want to divide it first by 10. And the reason why we're dividing by 10, if we want a value 0 to 10, by the way, if this part doesn't make sense to you, just worry about the output. If you want to know why this works, then follow along with this. So we are dividing this random number that's returned by 10. And the reason we are doing that is that when you divide a number by 10, the remainder has to be between 0 and 9. It cannot be greater than itself. It cannot be smaller than 0. So, you know, you can plug it into a calculator if you don't believe me and try it out. But I said I wanted a random number 0 to 10. So what I need to do is I need to include, because this is 0 to 9 right now, plus 1. So this returns a pseudo-random number. I can get rid of the extra comma brackets. And what I mean by pseudo-random number is something that we will look at later. So this is dividing it by 10, as I've mentioned, which will result in a 0 to 9 range. And we're going to add 1 to that range. So it's now a so the return value, so if it returns a 9, it will become a 10. If it returns a 0, it becomes a 1. So it's actually really now a 0 to a 1 to 10 range, not a 0 to 10. So there are other ways to handle this to get 0 to 10. You know, if you want to work it out, it's up to you. Now this is going to return a pseudo-random number. So the next thing that happens after it sets this variable, it asks the user to take a guess what its favorite number is. The user guesses. And that's when we declare this fave guess that we initialize this fave guess that we declared up here. It then drops to this while loop. And what happens is it goes, if this guess, is not equal to what this random number is, then it's going to say, hey, no, you got the wrong answer, take another guess. And if that guess is wrong, it's going to repeat this over and over again. So while this is true, keep doing what's in here. When this is no longer true, go out here, and you'll get a correct. That is my favorite number. Good job, puny human. Sorry, I like imagining the computer as being angry still. There we go. That's a little bit odd. I don't know why that happened. Okay, we're just gonna... Sorry, I'm just seeing some weird things there. Okay, I'm just going to type that in. That's where we get our rand func from. Now, if for some reason, I don't know why it's doing that, but okay. If for some reason you didn't understand what I meant here, because this is actually a really complex idea, just remember, think about it this way. When you want a random variable, or a random number, start with the largest integer you want, and then start with the lower side of it. So this 10 to 1 here. There are other ways you can approach this, which we'll talk about in later lessons. So as I said, there's a problem with this code. Let's run it. Oh, okay. Give me 1 second. Where have I... Oh, I see where I've made my mistake. No, I don't want to run that. What we're going to do is we need to set our null here. So let's just quickly do that. Let's try that one more time. If you get your semicolon there, that's kind of important. So I'm going to pick a number I know is not to be correct to begin with, just to make sure this while loop works. We know the values in between 10 and 1, or 1 and 10. And by the way, when I said pseudo-random number, we're going to talk pseudo-random number. What I said is it's pseudo-random because it actually isn't truly random. And when we get this to work correctly, it's going to favor, regardless of how you do this, lower values. So nope, 55 isn't my favorite number. Let's try 10. Nope, not 10. 9. Nope, 8. 7. 6. 5. 4. 3. It's going to be 2, by the way. 2. 2 is my favorite number. Wait, how did I know it was going to be 2? Let's try that again. Let's try 0. Nope, 1. It's going to be 2 again. Hey, 2 is the correct number. Good job. So what's actually happening here is it's not getting a random number. It is, but it's not actually truly random. This is not even pseudo-random at this point. And let me show you what's happening. What we're going to do a std cout, and we'll do rand. Remember, this is going to return a value between 0 and this massive number here. And we're going to do an end line. Ooh, sorry. Std, standard library, end line. And for some reason, I either skipped a bracket or deleted it by mistake. Sorry. We'll run that. And you see we have a random number there. And in fact, actually, we're going to add one more thing in. Now that you've seen that random number, we're going to actually add a couple more things in. We're going to add another std cout. And we're going to do this one as fave number. So you just want to have a little bit of a cheat there. And we'll do another std end line. Sweet. When it does that, by the way, look at that line for an error. There's most likely some problem in your code. I forgot one of the colons. So now I'm just going to put a space there, and I'm going to grab this bit, and I'm just going to copy it twice. So I have 3 random numbers, and we'll also see our favorite number there. So I'm going to run it. You're going to see a 2 on our favorite number. You'll see the same number for that first one. Yep, we got the same number. We have that 6334 there. In fact, actually, let me just write these down. So if you don't remember these numbers in a minute, let me just move that over there. This is, sorry, that was the wrong key. This is 18467 currently. This is 2334. This is 26500, and I forgot the extra stroke there. And we know that this is 2 already. So let me just close it out. We're going to get an error because it's expecting an input. If I go to my error list, it expects an input. It's also giving me a random error for something up here. I do not know why it's doing that. So, in fact, what I'm going to do is I'm going to do that should deal with that issue. So, just very quickly, or not. Again, let's compare these numbers. We have the same numbers each time. I am just going to delete this because it's going to drive me up the wall. Well, what we need to do is we actually need to randomize this in a way that actually makes it a pseudo-random number generator. So the way pseudo-number generators work is it is based on the computer's time. It's based on the clock. So we need to initialize that sort of setup. So what we're going to do is we're going to use a new include. We're going to include time. Actually, we're going to include C time because it's not a standard C++ library. It comes from the C library. So from this, we are going to get our time function. The next thing we need to do is create a seed, a random seed. So don't worry if you don't understand what a random seed is yet. In fact, we're not going to do too much with it. We're just going to declare one. So that's going to be seed, or srand for that seed. We're going to use our time function, which is coming from our C library, or C time up here. And I'm just going to set it to null. You can do other things with this. So what's happening here is now that what's going to happen is when we call our rand function, it's going to use a random seed based on the time of the computer, which will cause these to be different numbers each time you load in. So let's load it up. And you'll notice that we have a 1 instead of a 2, and our numbers here are different. Let's close this out and make sure it continues to work correctly. We now have a 4 instead of a 1 or a 2. So now our code is working correctly. I'm going to delete all of this. And that gives us, I'm just going to run it to make sure I haven't missed anything. Probably want to comment out the cheat part. Oh, we have a 9. I'll just put that in right away. Amazing! 9 is my favorite number. Good job. I'm just going to comment that out so that it doesn't cause any issues. And cheat line for debugging purposes sets our random seed based on time. Time is retrieved from ctime library. Srand and rand are retrieved from our C standard library. Okay. So that covers the 3 challenges I set for you. Now, I did mention one at the start of the video last week, which was a sort of test challenge to explore some stuff. And instead of just, having you worry about how to do that, I'm just going to show you it. So, you might recognize some of this code from earlier. Let me just quickly uncomment this. I've taken the stuff from last week's lesson. That was weird. Taking the stuff from last week's lesson, which was, get the size of bool, get the size of integer, get the size of float, get the size of double, get the size of character. So I say last week's lesson, I mean the second lesson. And I have now added in some extra bits to it, where we can get the actual size of these variables. And what we're going to do to get those sizes is we're literally going to bring in a new library called limits. This gets us the numeric limits. Love how this comment doesn't go crazy. And it's going to print the size of the primitive variables. I literally just copied the code from earlier. And I put in new bits. So we want the minimum. So, type in our usual standard C out, minimum value for a bool. And then we call up the standard library for our numeric limits, which comes from this library. we say which variable we're looking at, and we declare after that, after these two colons, what we're doing with it. We want the minimum value. So this returns the minimum value. Then we do the maximum value. We repeat this for the integer, min and max, the float, the double, and the character, which will have an interesting kind of response. If you want to understand this one, I challenge you to do a little bit of reading. Go back, look up some, not go back, but go to Google, look up, some information on characters. Now, there are some other things we could put after these colons. We could put, for example, is signed, and we'll get a bool value, either saying true or false. We can even check, is the value infinite, so has infinity. And again, it'll return a bool, true or false. But let's just quickly run this so you can get the actual sizes of some of these variables to correct from the second lesson. Alright, and as you can see, we have our bool has a size of 1 with a 0 and 1, true and false. We have our integer, which there we have our maximum value and our minimum value. Notice there is a single digit difference. And again, we have a really large number here. This is going to be move that decimal over 38 spaces that way with a whole bunch of zeros in front of it. And then in this one, move the decimal over 38 spaces the other direction with a whole bunch of zeros trailing behind. And then same idea here, but 308 zeros in front and 308 zeros behind. As you can see, our character returns a C as its min value and something weird there. If you want to understand this, go and look it up. I also do recommend reading a couple of articles which I've included as links that are kind of related to some things that we should understand when we think about encoding. So, all of that said, I hope you've enjoyed this lesson, and I will see you next week when we discuss other functions, such as our if function and our while functions, a bit further. So that said, make sure to leave a like if you have enjoyed this video. It lets me know I'm bringing you content you appreciate. If you want to see anything in this tutorial series which I've not covered yet, please let me know, and I will try to see if I can include it or where I can fit it into. Comments are appreciated, so it lets me know what you guys want. That said, I hope that you have a wonderful day.